In our previous video about parallelograms, we saw that the opposite angles of any parallelogram were equal to one another. That is, these two angles marked in white, the opposite angles were equal, and these two angles also were equal to one another. We proved the same. Now, in this video, we are going to consider if we can say anything about the sides of a parallelogram. Looking at the parallelogram which I have drawn here, it's obvious that the adjacent sides, that is the sides which are next to one another, they are not equal. One is very long and the other one is short. But what about the opposite sides? Can we say anything about the opposite sides? That is the purpose of this video. Let's find if there is any relationship between the opposite sides of a parallelogram. So in order to do that, let me divide my parallelogram into two triangles by using the diagonal. So I'm constructing a fresh parallelogram here. Yeah, this one. And the diagonal of the parallelogram. Let me first call the parallelogram as ABCD. And a parallelogram consists of pairs of parallel lines. So we have AD parallel to BC, and we also have AB parallel to CD. Now, for the purpose of our video, let us take AB parallel to CD and construct this diagonal BD. A diagonal is nothing but a line which connects the opposite vertices, or I can say the non-adjacent vertices. So the BD is the diagonal, and for our purpose, BD is the transversal. So exploring any property of parallelogram, we require to apply the properties of parallel lines, because parallelograms are constructed with pairs of parallel lines. So now we have AB parallel to CD and BD is the transversal. So this diagonal has divided our parallelogram into two triangles. One is triangle ABD and the other is triangle BCD. ABD, or if I have to find the congruency, I would have to rewrite it as CBD, because A, and let us compare the side A, the angle A and the angle C. We already know that they are equal. So I have to write in brown, triangle CBD. So we already know that angle A is equal to angle C. The opposite angles of any parallelogram are equal. We have proved it. And what about the next one? Now consider AB parallel to CD and BD as the transversal. We have two alternate interior angles, right? So this angle and this angle, they are alternate to one another and they are on the interior side. This is just the application of properties of parallel lines. You have a parallel line and you have a transversal. You see that the alternate interior angles, these two angles are equal to one another. I have just used that property here, right? So I can write this as angle ABD is equal to angle CDB, right? Angle CDB. Fine. And what about any other congruent part? We have two angles congruent, and of course the third angle also has to be equal. But is there any side which is equal to one another? Nothing is equal, but BD is common to both the triangles. BD is the transversal and BD is common to both the triangles. So we can say that both these triangles are congruent to one another. So we conclude that triangle ABD is congruent to triangle CDB. Because these two angles are equal, I'll have to alter it a bit. Triangle ABD is congruent to triangle CDB, right? So we have established the congruency between the two triangles. So we have the proof that a diagonal, any diagonal, divides the parallelogram into two congruent triangles. So this is what we have established now. BD, the diagonal, divides parallelogram into two congruent triangles. And why was this useful? This is useful because by CPCT, or by corresponding parts of congruent triangles, we can establish that this side and this side, AB, is equal to CD. The lengths of AB and CD are equal to one another. So, by using this property, which we have proved just now, that the diagonal divides the parallelogram into congruent triangles, we have established that the opposite sides in this parallelogram are equal to one another. So, this was the purpose of our video. What about the opposite sides of a parallelogram? We have an answer for this now. The opposite sides of the parallelogram are equal. And in the same way, similarly, we can also prove that AD is equal to BC, that is these two sides. Right? We can also prove that AD is equal to BC. So, opposite sides of a parallelogram are equal. And this is a very important property which you will see that we'll be using in many problems related to parallelograms. Thank you.